Okay, so first is ionic saline hydride. How ionic saline hydride form? So we know this thing that ionic means the ionic compounds, the compounds which when dissolve somewhere, when we dissolve ionic compounds, they just dissociate into ions and conduct electricity. Second characteristics is they are actually crystalline. For example, salt, sugar. If you rub the ionic compound between your fingertips, you will feel that this is not a powder like thing. This is a crystal type. Thoda hard you will feel, right? And in case of powdered compound, you will feel the smooth surface between the fingertips. So ionic compounds can conduct the electricity in liquid state or molten state, but in solid state they are like insulators. Okay, so compounds of dihydrogen form with most of the S block element which are highly electropositive in character. The lighter metal hydrides are LiH, BeH2, MgH2. In fact, the BeH2 or MgH2 are polymeric in nature, means they are the lighter hydrides. Ionic hydrides generally formed with the S block elements. Halina ki rab se faryad. I've already told you the hydrogen family or lithium family, you can say, because we are talking about the hydrogen here. So we will consider the lithium. So lithium family forms the lighter hydrides, and in this case the hydrogen accept the electron with and exist with a negative charge. Okay, so the ionic hydrides are crystalline. I've already told you they are crystalline structures like sugar and salt. If you just take that crystals into in the exposure of sunlight, you will feel some like sparkling light will come out after reflection. It will like it glow in presence of light. So this is the property of crystals. Non-volatile and non-conducting in solid state. Ionic compounds are non-conducting in solid state. For example, if you just make the electrical circuit and you just put both the ends into the solid salt, what happened? The circuit will not complete and bulb will not glow. But if you mix that salt in water, and at that time the salty water is the best conductor of electricity, and if you put both the ends inside the tumbler, what happened? The circuit complete. Ion just transfer that charge from one electrode to another electrode, and electricity will conduct. Okay. However, the metals conduct electricity on electrolysis, liberate dihydrogen at anode with which confirms the existence of H positive ion. Okay, whenever we pass the electricity through the ions, the hydrogen will liberate out from the anode. Remember this thing, whenever we do electrolysis or any process in a tumbler which in which we have this a compound in molten state or mixed state, the positive gas will liberate out from the negative terminal, and the negative gas will liberate out from the positive terminal. This thing you have studied in 8th or 10th class also. Okay. Saline hydrides react volatilely with water, producing dihydrogen gas. All saline hydrides, ionic hydrides, they can dissolve in the water, as because water is a dipole and hydrides are also a dipole, so they can mix in the water. Okay. Li- Lithium hydride is rather unreactive at moderate temperature with O2 or Cl2. It's therefore used in the synthesis of useful hydrides. Lithium hydrides is unreactive, means at moderate temperature it do not react with the normal gases like oxygen or the compounds of halogen family, and it will not produce the it will not synthesize the useful hydrides, because this is being a light, it can react, but we have to provide the special conditions for that reaction. We have to control the reaction by giving proper temperature, proper heat, and in presence of catalyst. Sometimes catalyst required to initiate the reaction. Okay. Next is covalent or molecular hydride. Dihydrogen form molecular compound with the p block. Ionic compound form with the s block elements. Covalent or molecular hydride form with the p block element. P starts from that carbon to the halogens. Non noble gases are not included in this because they have the complete octet. They do not react with the metals or non-metals for stability. Okay. Most familiar example is CH4, methane. Just before the class, some student told me that in CH4, hydrogen share its electron. NH3, H2O, HF. Means the most stable hydrides form with the generally with the halogen family, and other carbon is the basic compound. It can react with metal and non-metal and form amphoteric hydrides. It can react with metal also, it can react with non-metals also. Okay, being a covalent, they are volatile. They are volatile in nature, good conductor of electricity, actively participate in any reaction. Molecular hydrides are further classified according to relative number of electrons and bonds in the loose structure. In loose structure, loose dot structure, in previous chapter we have already studied about what was loose dot structure. Loose dot structure was like they just arrange the lone pairs or unpaired electrons around the central atom so that we can know how many unpaired electrons are there, how many lone pairs are there. So according to that, they are divided into three categories. First is electron deficient. Electron deficient means which have the deficiency of the electrons. After even after forming a compound or hydride, they still have the deficiency. They have the capability to accept more electrons. They act as Lewis acid or electron acceptors. So those compounds which are electron deficient, even after combining with the other elements, they can even accept the electrons, are known as the Lewis acids or electron acceptors. Second are electron-precise. All elements of 14 group from such compounds like CH4 which are tetrahedral in geometry. Precise means they after combining with the another elements, when hydrogen combined with that central atom, it get become stable. Now at this time it does not require any electron to combine with. So this is, we can say, the balance compound. Valency of carbon is 4, and here hydrogen is combining, 4 hydrogens are combining with the carbon, and hydrogen has 1 electron, so each hydrogen donates its electron to carbon and form a CH4 molecule, that is methane. So at this compound, it does not have any unpaired electron, it does not have any lone pair of electron. All the electron present in carbon and hydrogen are participating in bond formation. Okay, next is electron rich hydrides. Electron-rich hydrides means even after combining with each other, elements when combined with each other has a lone pair of electron. Extra pair of electron means at this time they has the capability to donate the electrons. They have extra electron. The compound have extra electrons. Okay, these are known as Lewis bases. Okay, and or we can say the electron donors. For example, NH4. In NH4, nitrogen has extra lone pair of electrons. It can donate its electron to other elements and combine with them. Next is metallic. Metallic, we have done with S block elements, we have done with P block elements. Now, metallic or the non-stoichiometric hydrides, or we can say interstitial hydrides, form with the D block and F block elements. They have the capability to form the metallic hydrides. But beta, one problem is there. In D block elements, people think that the metallic character become less, but still they behave like metals now. Whenever we move from left to right in the periodic table, the periodic character decrease and the non-metallic metallic character decrease and the non-metallic character start increasing. But most prominently in D block we have metals. Okay, and if F block, they are in F block we have some radioactive elements, some metals, some highly reactive elements. Okay, so they has the capability to form a highly reactive hydrides. Okay, and the metals of group 7, 8 and 9 do not form hydrides. There is a specific condition: group 7, group 8 and group 9, they do not form metal hydrides. 10, 11, 12 and go, when we go on further, they can form the metal hydrides. These hydrides conduct heat and electricity, though not as efficient as their parent metal. This is most important. Means that we know this thing that the D block elements has metallic characters. Metallic character, like they can conduct electricity in solid state. Okay, so when we talk about the hydrides, so they can conduct heat and electricity, because whenever the 7 group and 11 group element combined with hydrogen, hydrogen has metallic character, and that metal atom also have metallic character, so they combinedly conduct can conduct electricity more efficiently as their parent atom do. Singly, that element conduct electricity, but it behave like a like semiconductor. Okay, or you can say they can conduct a partial current through it, aparting, giving resistance between that. But their hydrides are the best conductor of electricity when they are combined with hydrogen. Okay, they are most always non-stoichiometric. Non-stoichiometric is like their shape and the structure is not fixed. Okay, they can exist in any shape or any structure. We know now that lattice, crystal lattice has proper structure, square, square shape, and trigonal, bipyramidal, triangular, and a rhombus, hexagonal. So they have specific structures. The crystal have proper structure, but in case of these hydrides, they do not have any structure. They can, the crystal can form in any structure. The structure is not fixed. The law of constant composition does not hold here. Constant composition, we have studied that proper amount of element combined together to form a compound in a fixed ratio. For example, in H2O, two hydrogen are there, one oxygen are there. So in H2O, in water molecule, proper ratio is there. But you can see in these hydrides, we don't have any fixed ratio. But they just combine and form hydrides, not in a fixed proportion, not in a fixed ratio. They can combine in any form, right? Recent study have shown that except of hydrides of NiPdCe and AC, other hydrides in this class have lattice different from that of the parent metal. But I've already told you that they are non-stoichiometric. The structure is not fixed. So they have just gave the exceptions. The hydrides of Ni, Pd, and CeAC, these have like different structure as their parent atom. The parent has different molecular structure, atomic structure, but when they form hydrides, they shows the different structures. Okay, and other compound shows different types. The property of absorption of hydrogen on transition metal is widely used in crystal reduction. Hydrogenation reaction from the preparation of large number of compound means the property of absorption of hydrogen. These the transition metals, the D block elements are known as the transition elements. They are used as the catalyst in the reaction. This PD is the best catalyst which is used in many of the reactions to start the reaction, to increase the rate of reactions. So this is the property of D block elements, that they can has the property of catalytic property, and they can reduce the compounds, means they can remove the hydrogen from the compounds in hydrogenation reaction, in which we used to prepare a large number of compounds. Okay, so most of the D block elements can be used as a catalyst, and we know this thing that catalyst only control the rate of reaction. It does not take part in the reaction. Only the reactants will combine and form the product. Okay, some of the metals like Pd and Pt are accommodate a very large volume of hydrogen, therefore can be used as a storage media, the property of high potential of hydrogen storage, and as a source of energy. So hydrogen is actually the source of energy. What is there in the sunlight? Hydrogen. In this chapter, when we go further, we'll study about the structure of sun, what is inside the sun. So there hydrogen is present. Now continuously the breakdown and combination of hydrogen molecule takes place. They combine together and form what? Hydrogen, right?